Everyone. So my name is Cynthia. I work at Datawire. I'm going to be talking about making Envoy sustainable. I got a lot of feedback from colleagues that this title was a bit hard to understand. Was I talking about like changes that Envoy was making or something else? And so to clarify, I'd like to re-engineer my title right here. If the slide is going to go, it may not. Oh, come on. Oh, there we go. Just took a second, which is how to be a responsible platform engineering team and have your service last. So I'm not going to be talking about any changes made specifically with Envoy. I have thoughts about that, but that's not what this talk is about. This is specifically about people who are deploying Envoy or other service meshes or API gateways, and how we can actually make those reliable and last. There's a lot of content to get through, so I'm going to talk really, really fast. Hopefully not too fast, but if you have any questions, I ask that you please hold them until the end because, as it turns out, this is quite a big topic. Okay, this is going really slow, so I'm just going to switch to a backup slide. 1 second. So we'll just swap to the backup slide. So we're going to set a scene because every great talk requires a story. So let's say you're a normal or not a normal feature engineer working on your service, and all of a sudden you notice a lot of problems are happening at the network layer, right? And lots of feature engineering teams are having this problem, so you talk to your bosses and you say, you know, I want to deploy Envoy or Istio or whatever in order to solve these problems because it can't easily be solved another way. And so your bosses finally say to you, yeah, we'll let you go build that thing. And since you've been talking about it, we'll even let you be on the team. However, you've never been on a platform team before. So one of the questions that you'll probably first ask yourself is, like, how are we actually going to build this service? You know, what are we going to optimize for most? Is it security? Is it availability? What are we doing? I think one of the core tenets that any platform team will agree is one of your core things that you want to do is you want to make it easier for other teams at your company or other companies to really build amazing services, whatever your definition of amazing is, right? You want to extract away this core component and make it easier so that way they just don't have to think about it. They just tell you what they want to happen, and it happens. They don't have to know all the internal details. Right, you want to help keep technical debt low with your teams because, right, in this one system where you're deploying Envoy or Istio or whatever, you're impacting every team who uses that. So you really want to make sure your technical debt is low. You want to ensure that Envoy is frequently updated, right? You want to make it easy to do the right thing, hard to do the wrong thing, so that way people don't shoot themselves in the foot. In other words, you want to keep up with Envoy, because these are the same goals that Envoy has. And even though Envoy doesn't always do the best, it's constantly getting better at them through the amazing community that's here and through lots of other contributions from other people, right? You know, the new adaptive concurrency stuff is a perfect example of like the last one, making it super easy to do the right thing without having to turn as many knobs, right? So you want to keep up with Envoy, but Envoy moves very fast. How do we actually do that? So maybe you start writing software, you get a team to work with you, right? And you start rolling out software, and then one day you roll out a bad config update or a bad change. It happens to everyone. And all of a sudden, when you want to update that component again, they say, we don't really want to do that right now. We've got a large customer using, you know, this right now. They're doing an evaluation. We don't want to roll out. Or maybe you start working with a new team, and they say, you guys are rolling out updates really fast. We kind of want you to pump the brakes. And so why are people not rolling out our software? We're building this amazing thing. We're constantly developing new features and new fixes. And you know, this is a very critical piece of infrastructure. So why are people essentially hitting the remind me a day later update, you know, for all of our updates? They should want to apply this because it makes it better. There's really two reasons. The first one is time, right? And the second one that, at least according to me, is poorly defined breaking change policies, or just one in some cases. And so I'd like to break these down and really understand why they cause problems. So why is time a problem, right? We like to think teams have a lot of time, but they actually have a lot going on, right? They have their own application updates. I mean, think about how often a node module updates, for example. You know, I mean, everyone likes to make jokes about it. Like, these updates happen all the time. Sometimes they're pretty massive, sometimes they're not. They have their own infrastructure to maintain. Even in like a serverless environment, they're still maintaining, their logs, their monitoring, what they're alerting on. It's not fully automated. You're never going to have a fully automated monitoring, alerting, logging setup just perfect, right? So they are going to have their own infrastructure to maintain. They have their own support issues, and they have their own feature work. You can sometimes see feature work pin multiple teams of a product down for months at a time because they just need to roll out a feature. This isn't always ideal, but it happens a lot, right? It's not because the team is unwilling to actually apply your update. They just don't physically have the time to do it because they have all of this other stuff going on. Breaking changes, I state, are really what happens more. A lot of people like to think, oh, this is just use semantic versioning. Semantic versioning gives us a perfect way of telling whether or not a change is breaking, and we've never incremented a major version, so therefore we've never had a breaking change. Hey, so is that slide just going to be used somewhere? No. I actually think semantic versioning can hurt us in some cases when we try to follow it too closely. And this is because semantic versioning got 1 to 2 things wrong, in my opinion. It states that you can tell if a change is breaking based purely off of your own code and documentation. And it also states that in order to release something else, you have to release a minor update, and someone actually has to apply that update. If you're going by the spec specifically, which I've definitely seen some people do. So this is an example code. It's slide code. It's absolutely terrible. Class C and above, you can presume is a library. Class D and below are, potentially someone using your library. So you have these two interfaces classes, A and B, and C provides a way to filter based off of A's. So this happens, everything is going great. All of a sudden, I as the library team decide, we should really be able to filter on B's. So I go ahead and add this method, and all of a sudden, even though the user hasn't changed their code, they've now got a build break. And what's worse is it's kind of hard to tell what behavior they were getting before, because unless I'm documenting when I'm adding these features, the user doesn't know. Was I filtering on A's? Was I filtering on B's? Who knows? Now, this is obviously ridiculous slide code, but you can imagine how this can happen in real world code. So sometimes adding a method isn't safe, and in your documentation, you may not have realized that someone was using both A and B at the same time. So you just add a new function thinking everything is fine, but someone now has to go change all of their tests, and make sure that they're filtering on the correct thing. This I've actually seen happen quite a bit. We like to think that changing lines is generally safe, and most of the time it is. Unfortunately, sometimes people will write tests with line numbers in them, either accidentally or on purpose. And as much as I would like to say, we shouldn't support this at all, this is still something that's going to happen from time to time. So I really wouldn't say we would want to support this, but this is something that happens that you're going to need to realize. Seriously, if you haven't searched through all of your code bases for a line number or something, do it, and you'll probably be terrified. At my previous company, we had LiveGrep, and so I was able to do this while writing this talk, and I found at least 6 different instances of us matching on a line number. 3 of them were in a logging utility, but they were still being used. What about this case where I've replaced A with method B, and I've marked it deprecated for a year? A lot of the cases in platform teams, I can see everyone who's using my library. My library isn't necessarily open source, so I can see everyone who is using my library. I know that everyone has moved off of method A and onto method B, right? I created the new function just in case there was some undefined behavior that broke that I wasn't aware of, but now no one is using A. Do I really need to call a major version break even though I'm removing A? Is this really a major API change if no one is using it? Obviously, if you're in an open source place, you can't say that for sure, but from a platform team, you may be in this case. Basically, what I'm trying to say is context matters a whole heck of a lot, and everything has trade-offs, so you should never take anything for granted. And that includes being able to assume that you can find everything based solely off of your documentation. If you don't talk with the people who are using your library and more often proactively look at what they're actually doing with it, you're going to end up missing things. And I think we've all experienced the pain of upgrading a library somewhere, and even though it was a minor version update, it's caused weeks of pain as we try to upgrade because they accidentally broke us. So how do we fix this as a platform team? Like, what can we actually do as a platform team, right? You make your upgrades easy, like really easy. And based off of where you are in the software world, you're probably thinking one of two things. Either you're already doing this, which you may be, but kind of doubtful, or that it's actually impossible to do this, depending on who you talk to, right? So I'm stating right now that if your upgrade cannot be done by an intern, you have a bad upgrade. And that may be fine, right? Like if it's a massive security thing, yeah, it's probably okay to have a bad upgrade and just rush it through by throwing bodies at the problem, right? But if every single one of your upgrades is bad, then you really have a problem. So for code bases you own, how can you make it easy enough for an intern to do? Well, the first thing you need to do is, like I said, you need to communicate with other teams, and you need to start documenting more than just a public API, because as it turns out, teams depend on more than a public API, right? And so what I like to do is I like to create a series of small agreements with teams, so that way we both understand exactly what is being agreed upon, and then what we can do is we can also let other people agree to an agreement that has already been made, so when I want to make a change, I know exactly who to talk to, right? So if I have this list of agreements and who depends on them, then I can very easily communicate with those teams. And the only requirement for an agreement that I have is that it must have a test. So if I want to make an agreement with someone that we will support 20,000 requests per second, that's great. All I need to do is write a test. And if I can't, afford the machinery to do a perf test for that, well, then I shouldn't be making that agreement because I can't guarantee it. And you should invest seriously to make sure your API is followed. I think this is where most people end up falling short, because I feel like most of us probably communicate with other teams and document more than a public API. So when was the last time anyone wrote a script to do an atomic code change? I saw Spotify did this morning, and so that's great. But most of the time we're dealing with YAML and Envoy, right? So why can't we just write a small Python script to move from YAML A to YAML B? Most cases, it's possible. If you're using, a custom control plane, you may be able to just do it in your control plane, because as it turns out, Envoy does a really good job most of the time making sure that there's always a compatible feature, even if it's defined a bit differently in configuration. So why can't we just migrate someone for them, so that way we don't have to have a break, or if we do have to have a break, we can just provide them a script that works on well-formed inputs. So we can say, here, we know you have this YAML configuration, this is changing in a new Envoy version, so here's a Python script that you can just run, right? It takes a couple of minutes to write when you're just dealing with YAML. If you have something more complex, obviously that's going to take time, but it gets easier over time. And then you can use custom lint rules to actually make sure that the configuration works, but is also doing the correct thing. We found a lot of people at Instructure, which is who I used to work for, which is what this talk is based off of, we wrote custom lint rules for not only just YAML correctness, but also correctness of what you were doing, right? So we were in a very highly distributed cloud environment where we weren't running multiple pods per host for a whole bunch of crazy reasons, so we made sure that you weren't trying to set timeouts of 1 second, because we're never going to be able to make a timeout of 1 second, when potentially talking cross AZ, when you're not talking locally and we know you're not talking locally. So really writing lint rules to validate, are you actually trying to do what you're trying to do? For code you don't control, you can't always guarantee that it will be easy enough for an intern to do, because they may not agree to the same every upgrade should be easy, or they may just have a different idea of what easy is, right? Easy is kind of relative. So what can you do? You give the intern time, right? If something can't be done because it's a very hard problem, you give them time, right? If you're testing a release the day it's released or the day an RC is cut, it's probably too late. If there's a massive change that the library provider didn't think was important enough, but you depended on somehow through some crazy mannerism, right? It's going to take you time to figure out what changed, how you need to change it, and how you're going to expose that to people, right? And you don't just want to run build tests, you really want to run a whole series of tests, which is where agreements can come in and helpful too, right? Where you can test all of these small things so you can validate that a release is totally fine. You don't necessarily have to fix these right away, right? You can just track Envoy master and say, you know what? There's going to be a change to the default timeout. So that's going to be a relatively small change, so I'm just going to push that off and let teams handle it later because I know it's going to be small, right? Whereas if it's a massive build break, you probably want to fix that as soon as possible because then it prevents you from even seeing new failures. You don't have to fix it right away, but this gives you the time so that way you can properly notify people ahead of time. Obviously, there are pros and cons of this. The essential work, though, is that you are moving work from all of the teams using your product to yourself as a platform team. So you are giving yourself more work, but you are lowering the amount of work that everyone else has to follow. Everyone else pretty much just needs to tell you what they want from your platform, right? And whether or not a script worked, maybe provide a couple code reviews if necessary, right? And sometimes that can be hard, especially if you're very distributed, but they get to do a lot less, but you as a platform team have to do a lot more. So this is going to slow down your velocity as a platform team somewhat, but I think you'll find it'll actually raise your velocity as a business because these teams don't have to worry as much about your upgrades. You've just given them a little chunk of time back. So you keep building, you think your tech debt is under control, you're using the same process that you've always used for feature teams, however, you're still noticing a lot of tech debt issues pop up. Why is this happening? It sort of falls back to what I said at the beginning. Tech debt is affecting more than your team and your customers, right? You are affecting tons and tons of people with this, especially if Envoy is everywhere. Envoy, in a sense, is sort of becoming a single point of failure. It's not really a single point of failure, but it's becoming something that everybody inherits, right? And everybody could inherit the bug, right? And remember, there are business politics in business, right? So your team image is actually kind of important, right? And you have to think about, if I were a feature engineer using this library or this product or whatever, if it was causing CI failures every month, would I want to keep using this, right? Even if it's only a short period of time where you get maybe 5 minutes of test failures every month, right? That can still be super detrimental to your actual cause because people won't want to work with you. They won't want to tell you what new agreements they want with this new feature, or they won't be able to tell you, yeah, this thing isn't working because they don't think anything is actually going to change, right? So team image matters a whole lot. But at the same time, realize that tech debt will always happen, so I'm not saying cut out all tech debt. It's totally easy because you can never cut out all tech debt. Tech debt is going to happen. So what you need to do is you just need to balance it better. I'm going to talk specifically about things that you can do during planning, but if you're really looking for things that will work at your business, I highly recommend talking to people at your business who are actually aware of this. Program managers are usually a really good place to start. And I guarantee you they'll tell you about like 50 different buttons in Jira that you never even knew existed that will probably solve all your problems when they're not broken, right? So when planning, the first thing that I like to tell everyone is keep it boring, right? You really, really probably don't need that cool thing right away. For example, an instructor, we didn't deploy XDS for our first 5 production apps that were behind Envoy. We were able to do it managing config the exact same way we always had been, which is pushing keys into console and then having a local script fetch those, merge it into one final YAML file, and then use Envoy hot restarter. Right? Control planes are amazing, they do amazing things, but they're also incredibly complex, as I'm sure you've gleaned from just a little bit of these talks that are talking about just a little bit of the problems they advance, right? And remember, every bit of technology you add adds complexity, even if it's a managed solution, right? A managed solution isn't inherently better, neither is managing a solution yourself. Everything requires trade-offs, and the trade-off that you should ideally shoot for is the thing that makes it as boring as possible for you and also works the best for your specific consideration. If you think those considerations are going to change, then you should probably set up a time to re-review what you decided on because you may come to a different answer and you may decide to start planning a migration, right? And another thing that I really like to ask whenever someone proposes that we use this new thing is they'll say, yeah, we'll just, throw in Envoy Lua filter or Envoy WASM. And the question is, do we really need all the functionality of that, right? We tend to say like, oh yeah, we need Kafka to do all these great things, but do we really? Do we really need to send millions of messages a second? Maybe we do, and maybe that's the best choice, right? Maybe we don't. And so maybe we can write like a custom lint rule that blocks certain functionality of features, right? So that way we can say, yeah, we're not ready to support that yet, because that's going to be really, really complex. So that way, as a platform team, we can roll out features as we plan, right? And again, like I said, you can lock some of it down with linters or whatever, where you can say, yeah, I just don't want people using that bit of functionality. By planning features ahead of time, you get a lot of benefits because you are actually understanding what you're building, and you've done competent, trade-off diagrams where you can say, yes, this is really the best thing for us. Planning is also a really, really easy way to just get stuck, right? Sometimes the best way to do planning is to work with a team on experimental stuff and just say, you know what, no one else can use this but this one team, and we're just going to work really closely with you, right? Don't let yourself get stuck just because you wanted to plan everything perfectly. Sometimes you're going to plan wrong. That's okay. Don't let it get you stuck, but don't always, go without. So as an example, I'd like to use Instructure's codebase, which I can't show you any pictures of. It was supposed to be open source by this talk, but it wasn't. If you want to go talk to the people who are actually in charge of it, they're sitting on the fourth row back right there. Their names are Christian and John, and they have Instructure on their badge. So if you want to go see what the actual codebase looks like, you can go talk to them. The first thing we did was we mandated this at the start, was every new feature required a tech plan, test plan, and then agreements with teams. Like I said, we did these small agreements with teams, and they were really easy to manage as long as we kept up with them, right? That first, getting everyone to understand this agreement thing, that was a huge hurdle. But now that we've been doing it, it's really easy to keep it going. The tech plan is where we sort of decide on yes, Redis really is the best for us over Memcached, and maybe that is because we don't have time to really look into it, and Envoy supports Redis right out of the box really well, right? It allows us to do that, and then the test plan is where we document all success, failure, fuzz, and chaos testing scenarios. Those were what we want every feature that we roll out to have, so we do that. We have a linter that powers automated code reviews and enforces best practices. So we as the platform team don't have to review anybody's configuration. We can just run a linter, and as soon as that linter has given it a +1, we don't care where they put it. We don't care if they put it in production right away. We don't care if they put it in development, in testing. It doesn't matter. You roll it out. It's your configuration. This linter is going to validate that it is correct according to us. So this isn't just Envoy mode validate, which is one part of the linter. We also do things like make sure that you aren't doing a potentially bad regex, or we make sure you're not using Lua because we don't want to support Lua at this point in time. We do all of that so that way we can ensure that as long as this linter is run, which doesn't require any manual interaction, this code is good. We constantly developed on Envoy Master. Our CI always fetched from Master, and we used nightly tests on Envoy to make sure that Envoy was always building and was always testing. So if a test failure came up, we got an immediate notification in our Slack channel, and immediate was truly immediate. It was either that night, or it was the next time someone ran a build, either locally or on CI. So we were constantly on top of Master, and we knew when Envoy was breaking for us. This had the effect where if it was a build breakage, we would have to fix it right away in order to keep developing on Master, so that way we could keep watching for failures. If it was just a test failure, we just logged about it in Slack, so that way we knew there was work to do. But again, we only had to actually fix it if it was a build break, which didn't happen too often. So it was really helpful there. We kept all of our meeting heavy days to one day. A lot of this requires reviewing with teams constantly, right? You constantly want to review these things that you're setting up with teams. You constantly want to review the code that they're pushing into production to make sure you don't need to add rules to your linter, right? All of this takes time, and we just put it on one day of the week, so that way it was really easy to plan around, because the rest of the days you could essentially avoid context switching. You didn't have to be like, oh, it's meeting mode now. We just had it on one day. We tracked all Envoy deprecations in config separately. Envoy actually has a flag for this now that makes it really easy. It will terminate the process if there's a deprecated flag that is run into, so we actually can just use that. And the essential process here is as soon as a config option was deprecated, we're actually able to completely migrate away from it using the whole, we would write a script, migrate all of our YAML over automatically, and then just introduced a lint rule to make sure no one else added it back in. And if someone did try, the lint rule would explain why we don't support that way anymore in case they were copying from like an old config somewhere. Like I said, we made the decision to not use XDS actually at all when we first started. Now we're actually using it for secrets. Again, we're doing this very piecemeal to make sure we can actually support the thing that we're supporting. This one I don't recommend for other people, but I would like to bring it up because it was something kind of weird we did. We actually put all of these sort of version improvements and agreements into a specific scheme, specific to Instructure. We called it Living Near Head. And really what it was is it was a way to communicate what we were expecting from consumers and what they should expect from us. This could work as a wiki doc, but we wanted to formally specify it due to a couple reasons that are sort of internal to Instructure. But like I said, this was really just trying to communicate to teams like, we want to build more reliable services, but in order to do that, we need to know how you're using our platform more concretely. So this is what we expect from you, and this is what you should expect from us. That's really all I have. If you have any questions about it, you can ask me on one of those links there. GitHub would probably be a weird place to ask, but I mean, I'm sure there's a way you can figure out how to do it. And I have 4 minutes because I talked really fast. So if anybody has any questions about concrete specifics or anything like that, I'd be more than happy. And without that, I hope at least I got you to think about some things in sustainability that you didn't think about before. Thanks.